Alright, so lesson 11.2, we'll look at areas of trapezoids, rhombi, and kites. Our objectives: find areas of trapezoids and find areas of rhombi and kites. So a trapezoid is a quadrilateral with exactly one pair of parallel sides. Parallel sides are the bases, and the height is the perpendicular distance between the two bases. So guys, trapezoids, we're familiar with this shape. We studied them in quadrilateral sections. So how do you find the area of a trapezoid? So the area A of a trapezoid is 1/2 the product of the height and the sum of its bases. So of course, these bases in a trapezoid, they do not have, in fact, they won't be the same length. It doesn't matter which one you call B1 or B2. But you'll have two bases of different length, and then you'll have the height being perpendicular to those bases. So those will be the three measures you need. The two sides that are parallel to each other, they won't be the same length necessarily, but they'll be parallel. So those will be your bases, and then you'll need the length of the height, of course. So taking a look here at our first example, one of Brianna's trapezoid-shaped totes is shown. Find the amount of material used to make the side shown. So what that's telling us, find the area of this side. That's how much material is used here. So again, the formula, area equals 1/2 base 1 or plus base 2. So add your bases together. Again, it doesn't matter what one you call B1, what one you call B2, but just plug them in. So 28 plus 58 times the height of 30. All right. And so you can plug all this into your calculator. 28 plus 58 plus 2 times 30. And you should get that the area is 1,290 units squared. So meters in this case squared. All right, so nothing too challenging there. Add the two bases together, multiply by height, and 1/2. All right, so a rhombus. Now we're going to talk about rhombi and kites. So a rhombus is a parallelogram with 4 congruent sides. A kite is a quadrilateral with 2 pair of consecutive congruent sides. So again, both these shapes, rhombus and kite, they should be familiar from the quadrilateral section. So the areas of rhombi and kite are related to the lengths of their diagonals. So as we look at this here, the area of a rhombus or kite is 1/2 the product of the lengths of its diagonals, D1 and D2. So again, these diagonals aren't necessarily going to be the same length, but to find the area, you just diagonal 1 times diagonal 2 times 1/2. So pretty straightforward here. Let's go ahead with example 3. We'll do one kite, and then we'll do example B, of course, being a rhombus. So doesn't matter what side you call diagonal 1, what side you call diagonal 2. Area is 1/2. Diagonal 1 we said was, we said diagonal 1 was actually. Again, it doesn't matter what one is, B1, B2. So this ends up being 60 meters squared. Area of the kite is 60 meters squared. And for the rhombus, all right, so this rhombus, this is where it can also, they can kind of try to trick you a little bit. Recall that the diagonals bisect each other in a rhombus. That was from the quadrilateral section. So this is 2 segments of 10. So call diagonal 1, call it 10 plus 10, 20, diagonal 2. Same trick there. They bisect each other. So this segment would be 12. So 12 and 12 diagonal 2. 4. And these are feet. So area is 1/2 diagonal 1 times diagonal 2. So that is 240 b squared. Alright. So that is how you find the area of a kite or rhombus. You've got to use the measures of the diagonals. Right. And then very similar to our triangles and our parallelograms, you can use area to find missing measures here. So one diagonal of a rhombus is twice as long as the other diagonal. So that's represented here. One diagonal is x, the other is 2 times x. If the area of the rhombus is 169 square millimeters, what are the lengths of the diagonal? So you've just got to use, again, the formula for area of a rhombus, 1/2 b1 times b2. So in this problem, area 169 square millimeters equals 1/2. Call diagonal 1, x, call diagonal 2, 2x. So if you solve this, 169 equals 1/2 times 2x squared. 1/2 times 2, of course, is just 1. 1/2 times 2 is 1x squared. Square root both sides, and you get that 13 is equal to x. So x is 13, so diagonal 1 is what? Units here are millimeters, so 13 millimeters. And the one that is 2 times that, of course, would be 26 millimeters. So you can do the same type of things we did in that triangles and parallelogram section. All right, you can do the same deal here with the trapezoid. Find the missing length of a base here. You got to use area. Again, our formula for trapezoids area is 1/2 b1 plus b2 times your height. So just plugging in, okay, height is going to be your 13 centimeters. Let's call 11 b1. Let's call x b2. Of course, area 177. So 177 is 1/2. Base 1 we said was 11 plus base 2 is x times height is 13. So just some algebra to do here. I'm going to probably multiply both sides by 2 to cancel my fraction. So that gives you 354 equals 11 plus x. 11x plus x. That's 13. So little distributive property here. 354 equals 13x plus 143. Subtract 143 from both sides, and you get 211 equals 13x. Divide by 13. X is 16.2. Our units here are centimeters, so 16.2 centimeters. So, kind of nothing really new there. Of course, your homework is going to be 5 through 13 all. And thanks for watching this video.